So you've came here because you are very interested in learning what's in store for you when it concerns the steam distillation of cloves. Well, first off, I want to say get ready to smell good because you're probably going to be smelling pretty handsome or pretty sexy by the time you leave the lab because everybody loves the smell of cloves. At least the majority of everybody does. And if you don't, then you're one of the weird ones. But anyway, let's talk about clove. I'm going to talk about the background of clove, talk about why it's used, how it's extracted, and a little bit about the clove oil that you will be gathering from the clove bud that we will have available to you in the laboratory. Keep in mind that the Blackboard page is going to give you a couple of other options. If you don't want to do clove bud, then you're more than welcome to substitute that for something else. But here's the drawback. We're not going to provide that material for you. You will have to bring in that material if you decide to do something else other than clove. Okay? So, if you go through the list and you find, hey, I would love to do cedar oil, then you'll be bringing in your own cedar bark or your cedar sawdust in order to extract that oil from that product. But if you choose to keep it with clove, we'll provide you the cloves. We'll make sure that you have them so that way you can start the lab whenever you want. Okay, so the very first thing that I want to do is I want to talk about clove before I talk about the advanced laboratory technique that will be associated with this experiment. So the first thing that you need to know about cloves is that the clove bud that we will be using, it will be the whole clove bud in the laboratory experiment, basically comes from the plant. So over here to the side, you will see a drawing of the clove bush or clove tree, whatever you want to call it. And then off of this bush or this tree, you basically will see the clove buds. So all of the red that you're seeing in this picture or this drawing is basically the clove that we will be using in the lab. So you can kind of see from that depiction that we can get many flower buds from one plant. So it's not a problem for us to basically gather cloves up and put them into a bag and take them to a grocery store and sell them. And because of that, they're fairly cheap as well if you go to the right grocery store. Why do people use clove? Well, clove is a very common cooking ingredient or a flavoring agent that's used in the kitchen. And it seems that most people will only use clove during the holiday season. So whenever you think about Thanksgiving or whenever you think about Christmas, you're probably thinking the smells of the holiday season, and that involves a little bit of cinnamon and a little bit of pumpkin spice and a little bit of clove as well. And that's what most people associate it with. However, clove should be used in sweet and savory dishes both alike, not just for the Thanksgiving holiday to basically put into your ham that you're putting into the oven, but you should also be using clove in various desserts as well, and you see that in various cultures throughout the world, not so much in the United States, but overseas you'll definitely see it. So, clove also has found its way into the tobacco market. And personally, I cannot stand the smell of a cigarette. The tobacco and the tobacco smoke that comes from that, it's not very pleasing to me. Some people love it, some people hate it, and I'm one of the people that do not like it. However, you can also buy cigarettes that are basically mixed in with clove or are clove, and you can light those cigarettes up and you can smoke them. And the smoke that comes off from those cigarettes are very pleasant. So a lot of times people that hate a normal cigarette will love a clove cigarette because they smell a little bit better, and other people don't mind them if you're smoking around them. And some people will even say that it does good things for your system versus tobacco and tobacco smoke itself. But keep in mind that very often these are blended, and the clove is mixed in with some of the tobacco that's inside of the cigarette. So you're still smoking tobacco, but it's just going to be clove tainted a little bit. As far as I know, I do not know of anything that's pure clove that you're going to smoke in a cigarette form. Medicinal uses, over the years, as you're seeing in the middle of the slide, clove has been used for many purposes other than culinary, and the very first one's dental painkillers. So a lot of times, if you have a toothache, instead of a what we use today to numb the pain, clove oil could have been used back in the day to do the same type of purpose. It also treats diarrhea. If you're pregnant and you've got morning sickness, clove and clove-oriented products can help you there. Excuse me. And then it will also help MS people quite a bit, or people that suffer MS people. So the clove oil can often help their ailments. But these are just kind of old school medicinal uses. There's other prescriptions and there's other medications that are out there. But if you're looking for an all natural substitute that doesn't really involve prescription medication and a little bit of chemical and a little bit of lab work, then clove could be a go-to thing depending on what kind of ailment that you're suffering. Very important down at the bottom, the active ingredient from the clove bud that we are very interested in is called Eugenol, Eugenol. And we're going to take a look at the structure of Eugenol in just a little bit. But I first want you to take a look at the name. And the very first thing that you should pick out is the OL ending. And keep in mind that OL means alcohol, right? So that means an OH group. I'm probably going to expect a structure that at least has one OH group on that structure, and that is an alcohol, and that's why the OL name is inside of that chemical name that's given on the screen. Eugenol has been reclassified by the FDA, and it has downgraded its effectiveness in pain relief. So there's other things that are out there that's much better than clove oil now, and clove oil was the go-to thing when we didn't really have any other substitutes or any other options for people, but it still kind of does its job, just not effective as what we thought it was going to be, and for that reason the FDA has reclassified it now. So Eugenol is going to be the name of the structure that you're going to be looking up in the Merck and online if you're using Wikipedia to find out more about the major constituent in the clove oil. So if someone says, what is clove oil? Well, clove oil is going to be a soup of different compounds, not just one, but that oil actually is made up of many, many different types of things. And one of the major things that's present is eugenol, and that's what we're focused on. So if I go straight to eugenol, eugenol has different properties than clove oil. Clove oil, again, is a soup and a mixture of different things, eugenol being one of them. But if we're looking at pure eugenol with nothing else with it, eugenol only, this is the essential oil from the clove bud. And that's why we say that, because it is the major constituent. Eugenol is one of the major constituents, not the only one. The other two are called methyl salicylate and vanillin. And if you've used the salicylic acid laboratory experiment already, you're probably familiar with methyl salicylate. And we also have a lab that deals with vanillin, and maybe you've done that one too at this point. And if so, good for you. You're very familiar with both of those compounds, but those are present in clove oil along with eugenol. So, clove oil is basically 16 to 18% of the mass of the clove. Now, what does that mean? That means if I take the clove bud into the laboratory and I weigh it out on a balance, well, I'm going to get a weight. And that weight, if I multiply it by 16 or 18%, that will tell me how much clove oil that I should be having in my product vessel if I extract the clove oil from the bud. All right. So let's say that I've got 5 grams. I would take 5 grams, multiply by 0.16 or 0.18. That gives me the range. And this will tell me how much oil I should be getting in terms of gram, right? Because I've weighed out clove bud in gram. So the calculation is going to give me gram of oil in the very end. So hopefully when I'm in the laboratory and I'm doing this experiment, I'll measure out my clove oil and maybe I will get close to that target number. Who knows? It's all going to depend on your laboratory technique that you do and the glassware setup that you prepare for yourself. Now, if you take 16 to 18% of that oil or that mass of the clove bud, that is the oil. But eugenol is only around 70 to 90% of that weight. So that means the real working relationship here is I'll take the clove oil, I'll multiply by 0.16 or 0.18 to give me a range of oil that I should be getting. When I get the range of that oil, gram-wise, if I really want to figure out how much eugenol should be present, then I should multiply that by 70 or 90%, 0.7 or 0.9. And that will give me a range of actual eugenol that I should be getting from this system. Okay, so hopefully that makes sense. Clove bud is made up of multiple different things. I'll extract the oil from the clove bud. That oil is made up of multiple different things. And I can kind of get a target. How much oil should I be getting? Then if I want to umbrella it down a little bit, what I would do is I would then multiply by 0.7 or 0.9, and that weight is going to be the specific eugenol weight that I should be getting in the laboratory. So eugenol is very toxic. So eventually in this laboratory, you will go to our stock and you will open up the eugenol bottle to compare your sample against. I want you to keep in mind that that eugenol that you will be working with is a toxic chemical that's very lethal in small doses. And that dose is given to you on the bottom of the screen. 5 milliliters, people, can kill a 2-year-old. So if you allow a 2-year-old to swallow just 5 milliliters of eugenol, they're probably basically going to be dead by the time they get to the hospital. So this is a compound that you do not want to take for granted. I know that we're talking about clove and clove oil and essential oils and natural remedies, but eugenol is toxic in larger quantities. And in this case, that larger quantity is just 5 milliliters. So it takes a lot of clove to eat, clove bud, in order to get 5 milliliters. I think that if you eat that much clove bud, then you're probably going to have other problems besides the eugenol problem, but it is lethal in its purest form. Now let's take a look at the structure of eugenol. Up here you're actually going to see at the top of the screen, that's kind of the clove bud plant up there at the very top for you. So the structure that you're going to be looking at, that you're going to be looking up, that you're going to be finding in the Merck is going to be over here to the right-hand side. And you're going to see a ring structure. Again, we're seeing another ring structure, and this is very common in the world of chemistry and the laboratory sciences. And that ring structure, again, is the benzene ring. It is a conjugated system. Double, single, double, single, double, all the way around without interruption. That is a fully conjugated system. So that is the benzene ring. And then up to the top, I see an OCH3 group. And then down here at the bottom, I see an OH group, eugenol, alcohol. There's the alcohol group. And then over here to the side, I see 1 carbon, 2 carbon, and 3 carbons in total that are hanging off on the right-hand side of that structure. And the ending carbons, that one and the one next in line, that has a double bond in between those 2 carbons. If you look at eugenol, it's going to say that it's classified as a phenylpropene. Now, we need to talk about what the word phenyl and propene mean. Phenyl is the word in organic chemistry that's given to the double bond system of the benzene ring. All right? So that's my phenyl group. And propene, prop is the prefix for 3. So it's meth, eth, prop. You need to start remembering those prefixes. All right? Meth is 1. Eth is 2, think alcohol, 2 carbons, ethanol, and prop is 3. So there's 3 carbons over here that are hanging off on the right-hand side of the structure, number 1, number 2, and number 3. And propene, we've seen this ENE ending before, and if you've not watched those videos yet for that particular laboratory, the ENE represents alkene, ALKENE, and alkene is for a double bond. So whenever you see the ENE ending, that means that there's a double bond between two carbons. So propene, 3 carbons in total, and there's a double bond that happens between one of them. So here's the double bond that's on that structure. So it smells like nutmeg or cinnamon. That's typically what people say that it smells like, even though they are classified completely different. The density is 1.06 grams per milliliter. The density of water is 1, so this is very close to density of water. Your boiling point for this is 254 degrees, so that's very high, and your pKa is 10.19. Now we need to talk about what pKa means, because I don't know what kind of background that you've had in general chemistry, and I'm not going to take anything for granted. So we're going to talk about pKa in the next video. We're going to walk through, just kind of understand what that term is basically telling me. And if you've seen it in general chemistry but didn't understand it, now's your second time to view it, and maybe you'll understand it a little bit more this time around. Also, at the very bottom of the slide, it says oil can be distilled, but why would a regular distillation not work? And that's something that we'll answer also in the next video. So stay tuned. This is just a little bit of background about eugenol, which is the major chemical structure that you'll be using this time around. And we need to talk about the processes, which is up next.